All right, we are at your very last day of notes for the year. 9/5, day 1, to have not a day 2. So this is it. And what this section is, it's just a shortcut, in quotes, because you'll see how short it is, for doing odd powers of sine and cosine. Integrating odd powers of sine and cosine. So you could use your reduction formulas, but this way also works. So it's just another way to do the same thing. So I'm going to give you the 4 steps it takes, and it should make sense. So first, you're going to take one sine or cosine from the odd exponent term and slide it over to the dx. So take sine, I'm going to put to the first. So you're taking sine to the first or cosine to the first. So you're taking one of the sine or cosines from the odd power, leaving you with an even power. And slide it over to the dx. What we're doing is we're going to be able to use that as the inside derivative and just do a simple power rule where we add 1 and times by reciprocal. So after you do that, you're going to take the remaining even power and write it as a power of 2. I'll show you that. Then your third step is to use a Pythagorean identity and use Pascal's triangle. Oops, Pascal's. Yeah. To expand. Now, each of your terms, so forth. So if you distribute the integral, distribute the integral, you can use power rule now on each term. So these 4 steps will make sense as we go through it. So let's start with one. So we're going to start with an odd exponent. Let's try cosine to the 7th x dx. Okay, so the first thing it says is you're going to take one of the cosines, stick it next to the dx, leaving an even power. So we're going to break it apart into the cosine to the 6th x times cosine x dx. So I still have cosine to the 7th. Now you want to write this as a power of 2. So I can rewrite this as cosine squared cubed. That's still cosine to the 6th. And then I still have this. So you always want a squared inside and then whatever power it takes to get you back to what you had here. Now the next step is to use a Pythagorean identity. So how do you rewrite cosine squared? So cosine squared comes from the cosine squared plus sine squared equals 1. So it's going to be 1 minus sine squared. So we will have 1 minus sine squared x, still cubed, cosine x dx. Now we're going to use Pascal's to expand this binomial that's cubed. And remember, if it's cubed, it's going to have 4 terms. So I'm going to come back over here. It's going to get a little bit longer now. So my 4 terms. 1, 2, 3, 4. And I still have my cosine x dx. That'll be multiplied by all of them. So the multiplication, the coefficients were 1, 3, 3, 1. And going through with powers of 1 doesn't do anything for us, so we'll start at the end. We have a negative sine squared that has to get cubed. So remember, the negative has to go with the power. So negative sine squared cubed. Then a negative sine squared squared. Then a negative sine squared to the first. And then we just have the 1 there. So what I want to do now is do all of the simplifying and distribute this cosine to all 4 terms and distribute the integral to all 4 terms. So we're going to break this apart into 4 integrals with cosine on all of them. So our first integral is just going to be cosine x. Doable. This next one is going to be a minus 3 sine squared and a cosine. Next one is going to be a negative squared that's going to go positive. 3 sine to the 4th cosine. And then our last one will be negative cubed is negative. That'll be sine to the 6th cosine. I'm almost done. Okay. So doing antiderivative here, we know that is going to be sine. Here we can do a power rule because remember we have the derivative of the inside is that cosine x. So we can, I forgot to put the dx on all these, but the cosine gets next to the dx, we throw it away, carry along everything else, and add 1 times by reciprocal. So if I add 1, I'm going to have 3 1/3. It's going to cancel that out and just leave me with sine to the 3rd. The next one, again, we've got an inside of sine. There's its derivative. We can do a power rule on the 4, throw that away. So that'll be a 5 and a 1/5. So 3/5 sine to the 5th. Then our last term, same thing. Inside derivative is here. Throw it away. Make it a 7. Minus 1/7 sine to the 7th. Plus c. So it's not bad, just take your time. Let's try one more. Oh, I got 2 more here. Let's see what happens. So number 2. Number 2. We've got an integral of cosine squared and a sine to the 7th. So I see the odd power here with some extra cosines, but that's going to be okay. Because remember, this gets switched out with this Pythagorean identity, it's just going to combine. So focus on this odd power, carry this along, and follow those 4 rules. So we are going to break this up. I'm going to keep the cosine squared. We're going to pull off one of those, leaving sine to the 6th, and then a sine. All right, so now we rewrite this with, make it a sine squared. So we make it a power of 2. So it'll be sine squared cubed. Now we rewrite it with the Pythagorean identity. This will be 1 minus cosine squared cubed. So now this has to get expanded. This and this are both going to get distributed after that to the 4 terms. So coming over here, I'm going to have an integral with 4 terms. I'm going to move this cosine squared to the end, only because I forgot it. And then I still have my sine. So now my multipliers are 1, 3, 3, 1. Okay, the 1 going through here doesn't change anything. I've got a negative cosine squared. That has to get cubed. Then a negative cosine squared that has to get squared. Then a negative cosine x to the first. So now I'm going to take this whole thing, distribute it to these 4 terms here. So my first integral is going to be cosine squared x sine x dx. My next one is going to be a minus 3. I'm going to have cosine cubed x sine x. Next, I'm going to have a negative squared, so that's going to go positive. I'm going to have a 3. I'm going to see, this is going to be cosine to the 4th. Plus 2 more, that's going to be cosine to the 6th with a sine x. And I still have one more term that's going to come down here. So I'm going to have a negative cubed. Let's see, that'll be cosine. This will be cosine to the 6th. Plus 2 more is cosine to the 8th. Sine x. Forgot the dx. Okay. Now we should be able to do power rule on those cosines, except for, I got to think about cosine's derivative is a negative sine squared, so I need a negative on every one of these. So I need a negative 1, throw all that away, power rule on the 2, it's going to make that 3 and a negative 1/3. So negative 1/3 cosine cubed x. Same thing here, I need the negative 1. It's going to make this positive. 4 and a 1/4. Over here, negative 1, 7 1/7. So negative 3/7. And the last term, I need negative 1. Change that. Gone. 9 1/9. Plus C. So again, all I can recommend is take your time. All right, this will be our last one. And it looks like it's a smidge shorter, so I'm going to fit it right here. Number 3. I'm going to go cosine cubed 3x sine to the 8th 3x dx. Okay, so again, we are focusing on odd powers of sine and cosine. Here's our odd power. So this is the one we want to follow that 4-step process on and carry along this. So we'll break this apart. We'll leave this as just cosine squared, 3x. Keeping the sine to the 8th, 3x. And then my other extra cosine, 3x, is down here next to the dx. And then since this is just cosine squared, I'm ready for my Pythagorean substitution. It's already a power of 2, so I won't have to do any Pascal's expansion on this one. So I'm going to rewrite this as 1 minus sine squared 3x. And I have this. Excuse me. Now, again, it's just distribute. We're only going to have 2 integrals to work with. Distribute and distribute. And the power rule should work on both of them. So I'm going to come over here. So 1 times this, so we will have sine to the 8th, 3x, cosine 3x dx, minus the integral. Here, I need to add my exponents, so that'll be sine to the 10th, 3x, cosine 3x dx. So, looking, can I do the power rule? Well, here's my power. The inside is sine 3x. What is the derivative of sine 3x? Well, it's cosine 3x, but then times a 3. Because the angle has a derivative. So I also need a 3 and I need a 1/3. So I throw all of this away, make this a 9 and a 1/9. So that'll be 1/27th sine to the 9th 3x. Over here, same thing. I still need I've got the cosine 3x, but I'm missing the 3 from the angle. So I can hit it with a 1, throw all that away, add 1 times by reciprocal. So it'll be an 11, so 1 over 33. Sine to the 33, 3x plus c. Not bad to end the year. Calling that good.